This is video 6. Make a better 6 than that. Video 6 for Computer Science 3344. We are still talking about context-free languages. Now we're talking about machines that can recognize context-free languages, specifically push-down automata, PDAs, but we haven't looked at an example yet. This is a PDA example. And I hope that all my black markers don't dry up all at the same time, but they just might. This is dark blue. Maybe this will work. Here's a language. L equals these strings. 0 to the n, 1 to the n, such that n is greater than or equal to 0. And quick observation about that, that's like our classic non-regular language. That's one of the easiest ones to prove it's non-regular using the pumping lemma. But it is context-free, and we can design a machine that actually will recognize that language. I'm going to, what I'm going to do is I'm going to slap the machine up here, and we'll try it out and see what it does. And then we'll reverse engineer the logic behind it. So rather than justify every step that I put up here, we ask that you bear with us and just kind of copy all this stuff down, take a look at it. The Q is going to have 3 states, Q0, Q1, Q2. What else we got? Capital sigma, well, that's easy to reverse engineer. It looks like it's going to be zeros and ones. Here's new stuff, capital gamma, the stack alphabet. It's got to have the $ in there. That's required. That's going to mark the bottom of the stack. And the only other one I need is a capital Z. And we'll see what role that plays in just a second. Q0 is Q0. This Q0 is the piece of the machine we have to specify. This Q0 is specifically that Q0. That's the starting state, the initial state of the machine. Same thing for $. The bottom of the stack symbol is $. That's what that means. And only one final state, Q0. And there we are. What's missing? Oh, 1, 2, 3, 4, 5, 6. There's one piece missing. Little delta. And, oh dear. I'm going to erase part of the board already because I would really like to be able to keep little delta on the screen. Take a good look at that. And I'm going to erase that and put little delta up here at the top and try to leave it alone so we can actually use it. As with all the other machines we've looked at, the transition function is really the meat of the tomato. That's what tells us what the machine is going to do, for crying out loud, when we try to run stuff through it. So that defines the whole thing. And here we go. These are the delta transitions. It's hard to write these up in a table, so I'll just list them. Little delta, Q0, comma, 0, $. Remember, we take ordered triples to ordered pairs. I'll write this one and talk about it, and the others I'll just write them up here. This is a set, possibly non-deterministic. There could be a choice here, but in this case there's not. Goes to Q1, comma, here's a weird one, Z $. Why do I claim that's weird? Well, we're replacing the top of the stack symbol. If we see a $sign on top, we'll in effect pull that off, pop it off, and put that back on. So there's an example of a string of stack symbols that we use to replace the top of the stack. This just says if we're in Q0, we see a 0 in the input, and we see a $sign at the top of the stack, then here's what we do. We move to state Q1, and we put Z $sign on top of the stack. Okay, less talking and more writing. Little delta of Q1, 0, capital Z, equals this set. It also has exactly one ordered pair in it. Q1, comma, ZZ. ZZ on top. Yeah, I did that on purpose. Close curly bracket. Little delta Q1, Z. I'm sorry, little delta Q1, 1Z goes to or equals this ordered pair. Q2 epsilon. Our first appearance of epsilon. We took something off the stack and we didn't put something back on. So in effect, we popped the stack. And 1, 2, 3, let's see the next one. Little delta of Q2, comma, 1, comma, Z equals this order pair, Q2, comma, epsilon. Hold up, little dancer. Is that what I just got through writing? Are those identical? No, I spy a difference. Everything is exactly the same except that's Q2, which kind of, I guess, begs the question, do we really need a Q2 if we're going to do the same thing we did in Q1? But I'll keep going. Little delta of Q2, comma, epsilon, comma, dollar sign, equals, again, every one of these sets just has one order pair, so this is a deterministic machine. Q0, comma, epsilon. Okay, now, an initial configuration, what has to be the start of our computation. Initial configuration also known as the starting point. Our initial configuration has got to be we're in the starting state, Q0, and we've got our entire input string. In this case, I'm going to use this for the input string, 0, 0, 0, 1, 1, 1. That whole thing goes there for the initial configuration, the starting point. And not only do we need the starting point, we also need that stack symbol in the bottom that's going to mark the bottom of the stack for us. So that's our starting point. We're in the starting state Q0. We've got an input string that we haven't done anything with yet, 0, 0, 0, 1, 1, 1. Because if you recall, before I erased it, the language we're going to try to recognize is 0 to the n, 1 to the n. And the dollar sign marks the bottom of the stack, but at this point it's also the top of the stack. Okay, stop talking and start writing. Let me see if the purple works. Okay, so I got to start with my initial configuration. Oh man, that is a really juicy purple. I like that a lot. Start at Q0, 0, 0, 0, 1, 1, 1, dollar sign. And the string symbol, everybody has to have their very own string symbol. The sideways T just means makes a transition to. And that's actually how I can remember what it is. It does look like sideways T. We make a transition to, well, let's see. According to this, what kind of transition do we make? Well, I'm in Q0, and I see a 0 in the input. I'm only going to pay attention to the very first symbol. Just like with our NDFAs and our DFAs and all that, we only pay attention to the next symbol that shows up in the input. In that case, this is 0, but we also have to take a look at the top of the stack. What do we do if we're in Q0 and we see a 0 in input and we have a dollar sign? Oh, look, here it is. If we're in Q0, we see a 0, we got a dollar sign, then we go here. We go to state Q1. Watch carefully. I've just now consumed that 0, so that 0 is gone. I've used that up. There's no going back. So I've just got 2 zeros left, 1, 1, 1. And the dollar sign, I take the dollar sign off and replace it with Z dollar sign. Look what I did there. Now remember, this third thing represents a stack. And you don't have to think about it real hard, or at least I hope you don't, that what we just now did was push capital Z onto the stack. That's what this step is doing. It's saying if you're in Q0 and you see a 0, push a Z onto the stack. And that's exactly what we did. Now, pick it up with this and go to the next configuration because we're doing a computation. So I'm in Q1, I see a 0 and a Z. Oh no, where am I going to go? Well, I'm in Q1, I see a 0 and a Z. Now, first off, you can absolutely, positively fall off the machine. There is reintroduced the possibility of unspecified transitions. And if we do that, then the string is rejected. As long as we can keep going here, ideally we will end up in a final state and the string will be accepted. If at any point we fall off the machine because there's an unspecified transition, then that means the string is rejected. Okay, we're in Q1. I said this already, but I'll say it again. We're in Q1. I spy a 0 in the input, and there's a Z on top. Look what it does. It moves to Q1. In effect, stay in Q1. The 0 that we just now ate up over here, that's gone. So in the input left, I'll have 0, 1, 1, 1. And it replaces Z. Look what happens here. It takes that Z off so it can get a good close look at it, and then turns around and puts 2 Z's in its place. So it takes that Z off that I just now looked at and puts 2 Z's in its place. Those brain gears are twirling now. Look what's going on here. as we're eating up zeros, what are we doing? We're pushing z's onto the stack. So far, I've eaten 2 of my zeros and I've pushed 2 z's onto the stack. Did that go too fast? Well, just pay attention. It's about to happen again. We're still in Q1. We see a 0, and there's a z on top of the stack. Now notice in both of these, they're serving very different purposes. But I'm only looking, the reason I'm using my underlines, that's my own convention, because I can't keep up with what's going on otherwise. That's the only thing the machine is taking a look at. It has to look at the current state, it looks at the next input symbol, and it looks at the top of the stack. That's how it figures out what it's going to do next. I've got room for a figure up here, so I'm going to draw a quick purple figure. Here's our machine merrily rolling along. It's got 2 things to keep an eye on. It's internally remembering what state it's in, but it's looking at our input, a one-way trip through the input, zeros and ones and all that, whatever it may be, dot, dot, dot. So we still got the input string just like we always had it, but now it's also got a stack, and it's looking at whatever's on top of the stack. It started off with just a $, but as it's pushing and popping and all that stuff, it's got to keep its eye on 2 different things. It's got to look at the next input symbol, yikes, and it's got to look at whatever's on top of the stack. That's what these 2 underlined things mean. Okay, I got off track again. Darn it, we'll never get done with this. I'm in Q1, yes. I see a 0, yes. There's a Z on top of the stack, so I'm in business. There is a transition specified. I go to Q1. Deja vu, I've been there before. And now I'm back. And I'm consuming this 0. Yes, the 0's gone. Now, here's the interesting part. It says take the Z off, take off this underlined Z, and replace it with 2 Z's. So look what happens. That 0's gone. I just now ate that up. But I've replaced this Z with 2 Z's, and the Z $ is still there from before. Look what's happened. All the zeros are gone, but I remember them. I remember that I saw 3 zeros. How do I remember that I saw 3 zeros? I remember that I saw 3 zeros because I pushed my little memory symbol, Z for 0. See what I did there? Z for 0 says I saw a 0 in the input. Now, the plot thickens. Let's see what happens. I think something different is about to happen. We're in Q1, except this time, look, our next input symbol is a 1. Q1 here. The next input symbol is a 1. We haven't looked at this one before, but look what's happening here. Z, the top of the stack. Yes. 1 in the input, Z, the top of the stack. We go to state Q2. Finally, get out of the state you're in. We move over to Q2. Look at this. Epsilon. We pull this Z off so we can look at it and replace it with nothing. Yes. So this 1 is gone. That first 1 is gone. I've got 2 1s left. I pulled this Z off so I could get a close look at it. This is me, the machine, looking at the top of the stack. And I replace it with nothing. Also known as pop that Z off of there. We just popped a Z off the stack. Why would we want to do that? Well, what we're going to be doing, looking down the road, we remembered all the zeros by pushing Z's onto the stack, and now, 1 at a time, as we're eating up 1s of the remaining input, we're matching them with the zeros to see if they match exactly, to see if this string is in the language. That go too fast? Well, watch. It's about to happen again. Something very similar. Makes a transition to what? We're in Q2. It's got to be one of these last 2 down here. We're in Q2. We see a 1. I see a 1. I see a Z, a 1 and a Z. This is it right here. This is the row I'm on. I stay in Q2. That 1 is gone. There's nothing here to represent that. I mean, every time, you'll notice every time, every single one of these transitions eats up the next symbol of the input. So that 1 that I just now used, that's gone. There's 1 left. What about the Z? The Z is replaced with epsilon. So I popped off yet another Z. And I'm left with 1 Z and the $. I jumped ahead of just a little bit. I underlined those because that's what I need to look at to figure out what happens next. Well, let's figure out what happens next. I'm in Q2. I see a 1 and a Z right here. I go to Q2. The 1 is gone. I've got nothing to put between the 2 commas. Oh, wait. That's the empty string. I can do that. There's nothing left. I've completely eaten up the input string. What about the Z? That's gone too. Epsilon. I could write epsilon $, but I'll just write $. Now it looks like we should be done there, except if we are done there, then the string is not accepted, because on the board that I erased prior to this, we only have one final state, and that's Q0. Well, look what happens. If we're in Q2, we don't have to consume any input at all. This is called a spontaneous transition, which is the fancy schmancy way to say, I'm going to make a transition even though I don't consume any input at all. It's equivalent of an epsilon arrow. So I'm not eating up any input symbol, which is a good thing. There's not any input left. But the $, if I see the $, on top of the stack, then I can do this. I can go back to Q0, my one and only one final state. The input, it was gone before. It's even goner now. No, that's not true. That was an attempt to be funny. It's still gone. Still, there's no input left. But now, not only that, but the $, itself is gone. Oh no, now I've got no place to go. There's no transition specified. But I don't fall off the machine. The input string is completely eaten up, and I am in the final state. If the input string is completely gone, and I'm in a final state, that's an accepting configuration. ACCEPTING. Accepting configuration. And I don't have a lot of faith in that red, so I'm going to try to switch back to the juicy black if I can find one. Accepting configuration. What does that mean? In a final state, and the input is gone. All the input is consumed. Input consumed. I'm underlining. I didn't mean to mark that out. Sorry. If I'm in a final state and the input string, it's just like school, isn't it? The lower I get on the board, the more illegible my handwriting is. I'm in a final state and the input is consumed, so that's accepting. Yes, you're in the language. Oh, wait. Oh, I didn't leave any room. I didn't say anything about the stack. Here's a weird thing. We don't care. We don't care if there's anything left in the stack. The stack could have had XXX, YYY, ZZ, $, and so forth. If these two things are met, if we're in a final state and we consumed all the input, then that's it. That's good enough. We don't even care what's going on in the stack, which might beg the question, why did we care here? And I'll address that question soon. Maybe not right this minute, but soon. Let's review what we've got on this machine, if we can. I said I was going to reverse engineer the logic of this. Let's see if we can. We start off in Q0, and look at this. This step says, if you're in Q0 and you see a 0, push a Z and go to Q1. Q1 is what's doing most of the pushing. Q1 is looking 0, 0, 0, 0. It might run into several zeros. We were in Q1 for a while. Every time it sees a 0, it pushes the Z. So I'm going to describe these two as pushing Z's. That's what I try to do at night. Pushing Z's onto the stack so that it can remember. Already goes beyond what an NDFA was able to do. It's pushing Z's so that we can remember the zeros that we saw. What are these doing? Let's see. Q1, Q2. When they see 1s and a Z on top of the stack, both of them, take the Z off and don't replace it with anything. So these are popping Z's. P-O-P-P-I-N-G. Popping Z's off the stacks. And step 5, that doesn't look like it's able to even justify its own existence. Why are you even there? It does take us to a final state. So that's what it's doing. After we've eaten up all the input, after the stack is completely empty, then we go back to Q0. Now, I was going to, wasn't I? I left a question hanging down here. Why did we even need this additional step? If all the input's gone and the stack's empty, why do we need to pop that off and go to an empty stack? I think it's going to be easier for me to explain that if I go ahead and draw the state transition diagram, which yes, we can do. The diagram often helps a lot. I'm going to get rid of all this purple stuff. Sorry about that. I hope you wrote it down. I hope I wasn't totally body blocking it the whole time I was talking about it. So, do I have? I thought I had. I did thought I had a state transition diagram. Oh, it's all scribbled and messed up. State transition diagram, STD. Q0, which is a final state, strangely. Do we want it to be a final state? Yeah, epsilon is in that language. We don't have to have any zeros and ones. The numbers would match then. Here's new stuff. When I go to Q1, I go with an arrow, just like we did before. I go in there with a 0. Q0 goes to Q1 with a 0. But I got to put some additional stuff here. We put a comma, and we say what happens on the stack. This says, when I'm in Q0, see a 0, I replace the $sign with $, as I go to Q1. We'll use another arrow in here, a little arrow on top of that arrow. $sign goes to $. I hope that's large enough that you can read it. This says in the transition from Q0 to Q1 that's represented right here, when I see a 0 in the input, I consume that 0, and I replace $sign with $, as I go to Q1. Okay, this one says if I'm in Q1 and I see a 0, I'm going to stay in Q1, so there's our first self loop of this machine. I consume that 0, and I replace Z with 2 Z's. If I did that correctly. This says if I'm in Q1 and I see a 1 and a Z on top of the stack, then I go to Q2. I'll need an additional state, Q2. I forgot what I said already. If you see a 1, you replace Z with nothingness. Replace Z with the empty string. In other words, pop off a Z. Pop a Z. That's what we're doing. And then here, Q2 got a 1. It stays in Q2 and also pops a Z. So far, so good. 1, 2, 3, 4 arrows. This one's missing. If I'm in QZ, I'm in QZ. In Q2, and there's no input left, and there's a $sign on top of the stack, then I go all the way back to Q0, way back here, all the way back to the final state. That's consuming nothing. That's a spontaneous transition, an epsilon arrow. But, whoops, that arrow came too soon. I take the $sign and replace it with nothing. Now my question was, is this redundant? Do we really need this? Why don't we just pop a Z and forget about the $sign and just say we're done? Maybe make Q2 a final state. Well, we can't make Q2 a final state because Q2 is the one that's doing most of the popping of the Z's. This transition from Q1 to Q2, here's the life story of a string as it goes through our machine. We start here, we see a 0, okay, let's get this ball rolling. We push a Z for the 0. We can't stay here. We can't stay here. This is the final state. And we don't want to recognize the string 0 all by itself. Heavens no. We want to start the ball rolling of remembering the zeros that we're seeing. Q1 is counting the zeros that we see by pushing a brand new Z on top of the stack for every 0 that we see. 0, 0, 0, 0, 0. Oh, look, here's the first one. With the first one, rather than stay here, I can't stay here because I can still get zeros in the input, and I haven't fallen off the machine, and that would be bad. So as soon as I cross the line over into 1 land, then I have to eat up the 1 and move over here to Q2. Q2 then does the same thing. It pops the Z off the top over and over and over, popping off the Z, popping off the Z, popping off the Z. When we get down to where there is no input left at all, no input string left, then we make a spontaneous transition back to Q0, popping off the $sign. And you might think, you know, we're going to be in a final state. Why mess with the $sign? It hasn't done anything to hurt us. Well, let's hypothetically and temporarily change this. Let me see if I can handle this. Replace a dollar sign with a dollar sign. Just leave it there on the stack. That doesn't hurt anything. Yes, it does. If that's the string that we just now recognized, replacing dollar sign with dollar sign says, you know what? You can start all over if you want. You can have some more zeros and some more ones and go through the machine again. That was so much fun. We don't want that. That's not in the language. This is 0 to the n, 1 to the n. So we eat up that dollar sign on the bottom of the stack. We do that on purpose to say after you've consumed all the input and you're back down to just that top of the stack, now the bottom of the stack, one and the same character, the only thing left will be the dollar sign. Then pop that dollar sign off so that you can't leave Q0 once you get back there. So there's actually several things going on here. We could actually, if we wanted to, before we've eaten up all the ones, we could make a spontaneous transition. If we had other things down here that said, okay, just follow the epsilon arrow, go back to Q0 and be done, take a shortcut. But we can't do that. We've got to eat up all the input. Being in a final state alone is not enough. If we haven't eaten up all the input string, then the string is not accepted. Being in the final state is not enough. Eating up the string. We had the string all eaten up. All of this 000, 111 was eaten up while we were still in Q2. But that's not a final state. We had to have a way to get back home. And we used our little magic symbol here for the top of the stack. I'm sorry, that's a symbol for the bottom of the stack. But once again, it rose to the top of the stack, and we popped that off just to bring us back to Q0 so that the string would be recognized. Everybody's happy, and our work is done, and it's all put together. And that's one example that took up all of this time in an entire video. Yeah, there will be homework based on this, and we will discuss that. Watch your email. But for now, I'll see you online.